lecture number is wrong. Okay, today we're going to talk about files, okay, um, and this is based on chapter 14 from the textbook here, okay. So let's just talk a little bit about this, okay. So pretty much all the code we've done so far. The code has been transient, as in they exist only in the notebook. As soon as you exit the notebook, everything, all the variables there that you've created and stuff and calculated, those are lost, right? And in certain cases, you might find that maybe it took a long time to calculate certain values, right? So maybe back in one of the earlier things, maybe you're calculating I don't know, the Fibonacci sequence recursively or something, and one thing you can do is you can create a dictionary where it keeps track of all of the values, okay, and then anytime the function asks for a new value, it can go out and compute it, but then after it computes that new value, it stores it in the dictionary. And you might find that you've invested a lot of time in developing this dictionary or something, and you don't want it to just disappear, and you want a way to kind of save that object. And so that's what today's lecture will cover, kind of saving objects and then being able to read them back in, okay? And so this is the idea that of persistence, meaning they need to store their data, somewhere on the hard drive, and not just have everything disappear as soon as you close your notebook or close your Python session. Okay, so kind of the basic operator is going to be open, okay? And so to open, you just use open, and then you'll generally give it the name of a file to open. So that could be filename.txt or some other kind of thing, and then you give it some kind of option, okay? So W will be for writing, and then R will be for reading. So there will be some cases where you want to open the file and you want to read it, and you have no intention of modifying it, okay? And then in other cases, you want to write to a file. And so open with W will write the file. If the file already exists, running open on this and then W was going to wipe out that file, okay? So just be a little bit careful. Okay, there's also there's other options that you might see. You might see a B for binary. So everything you can always look up Python open documentation, and then so I generally recommend always going to docs.python.org. This is going to be the official documentation. It's going to be a little bit more technical. You can always look up Python open, whatever function it is, and then tutorial, and you'll find a bunch of tutorials and stuff. Pretty much anything that comes from docs.python.org will be official and vetted and clean. There's going to be a lot of other websites. Usually the first page of Google is fairly good, but you always have to, W3 Schools is generally trustworthy. But generally, you also have to just be careful. There's a lot of people who post stuff that maybe don't know 100% what they're talking about. So just be a little bit careful there. But anyway, you can read about basically open. Okay, so here's open, and then as you now this is the tutorial. That's why I'm like, why am I not finding what it is that I'm looking for? So here we want open, and here's kind of the different options that you have. The mode, you have read, write, and there's binary mode, text mode, There's plus mode, which is you can update, okay, and it will append to the files. Okay, but anyway, so here we're gonna create a file if it doesn't already exist. I think it already exists on my computer, called output.txt, and we are going to open it, and we're going to call this thing fout, okay? And this is going to return a file object that comes with methods that's going to allow us to kind of write it, right? So here we're going to do line 1 is this string. This is the first line of text, and I end it with /n, which is kind of the new line character. Sometimes on Windows machines have a new line and carriage return. You'll get a /r/n. It all depends. So the idea of a carriage return was that, so imagine like you have this old school typewriter, and the old school typewriter, as you're typing, the little thing goes, it goes, I don't know, can you imagine like the piece of paper, right? So you get the paper on the typewriter, and then as you're typing, this thing goes chugga 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 as each character goes on, and then when you hit the end of the line, you hear a ding. I don't know, you have to think of like these old-fashioned movies where they're typing. You hear a ding, and then you hit enter, and it rolls the paper forward, and then somebody then takes the carriage and slides it back, right? Chugga 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 ding, and stuff like that. So anyway, on Windows machines, they have one carriage return, which brings the cursor back to the front of the line, and then new line, which is the equivalent of advancing the paper. On Mac systems, it's just /n. So I don't know. Okay. Anyway, it's called CRLF, carriage return and line feed, which, but anyway. So anyway, we write file out, write this line to the file, and it tells us it wrote 32 characters to the line, and that's that. Okay. If you call write again, it's going to add the new data to the end of the file. So this will be the second line of text, and then it writes it out there. Okay. And then when you're done writing, you should close the file. So you say, here's the file, close it. Okay. And that's it. Okay. And then when you close the file, it frees up the system resources dedicated to tracking that file. For something like this, it doesn't matter. But if you might have like a huge file, right? You might have like all of the text from Project Gutenberg, and you're doing some kind of giant text analysis with these huge files. And if you forget to close the file, it's going to use up some resources. If Python detects that there's no way for you to interact with this file anymore, like let's say you open up another file and you call it fout, so that that original file no longer has a handle to for you to interact with it, then Python's garbage collector will automatically close the connection and free up those resources. Okay. You can also use the operator with, okay, or the keyword with, and that will automatically open it, and then when the code is done, it will automatically close it, so you don't have to manually call, on this file, the output file close. So it's going to look something like this. You'll write with, and then here we open the new thing, and we're going to call it with as file or fout or whatever you want to call it. Okay. And then you run your commands here, and then as soon as this code chunk is done, it's going to close the file. Okay, so this will open the file and write lines to it, and then later you can then open the file again. Okay, this time in read mode, and then what we're going to do is we're going to iterate through each line in the file. So for I in file, maybe I should call it for line in file or something. We'll say print out the line, and it prints out exactly what we wrote to it. This is the first line of text. This is the second line of text. And if I find that file here, indeed, it has exactly what I have here, right? So that's just interacting with a text file. Okay. When you use the that command write, okay, it's expecting text text data, so strings, and so the easiest way is you can convert strings, non-strings, to strings using the function str. Okay, and this is going to open up all the string methods and stuff like uppercase and lowercase stuff. And if you don't convert things to strings, then you're going to run into problems, right? So here I have x is 42.3, and then I say y is going to equal x plus is my favorite number. Because x is not a string, I can't add these two together. Okay, but if I do y is equal to string x plus is my favorite number, then I can combine these and we get 42.3 is my favorite number. So so that works out. Okay. And then another alternative to using string, okay, is to just use the format operator. Okay, the format operator is the %. It's the same symbol that we use for modulo division, you know, giving the remainder for a division operation. But this is applied to strings, and it comes with what we call format sequences. Okay, and so again, you can always, oh, I don't want to do that. Open a new tab. So there's format sequences, and these are kind of the different conversion things. So you can have decimals and octal and hexadecimal and exponential and whatever. Probably the most common will be decimal, D for decimal, G for floating point, and an S for strings. Okay. I guess there's other ways. S basically applies string here. Okay. And so anyway, this is how it works here. So back here I had like string of x plus this thing. Okay. Here I just create a string that says %d is my favorite number. Okay, right? %d is my favorite number, and then I give it the format operator, and then I provide it the object x. Okay, and so because %d says make it an integer, Python takes this x, which is 42.3, and it's going to format it as an integer and make it a string that fits into y. And so when I print out y, it comes out 42 is my favorite number. If I run it again using %g, okay, g will preserve, will make it a floating point number. And let me just make sure I'm not missing any chat questions here. It's going to keep it 42.3 and put it in here. Okay, so here I don't need to like use some kind of concatenation, a whole bunch of like plus signs and stuff. So I don't know if you've ever tried to like create a string in R using different variable names, but it can be frustrating because you have to use like paste, and it's like paste quote unquote this is, and then variable name, comma, something something, comma, variable name, comma, you know, it can be a little bit annoying because you have all of these things. With the format operator, you can provide it multiple placeholders and a tuple of values. So here I've got x is 42.3, age is 85, and then rather than having to do my age is quotes plus age, quotes, comma, and quote plus X or whatever, I can just put in these placeholders, right? I can just put in the format placeholders, %D, %G, and then give you the, the format operator, and then the tuple of the values that I want passed in. So I can do age, comma, X, right? Maybe I'll just, so, contrast this to having to do something like this, right? You'd have to do my age quote plus age. You'd have to do string on age plus something like this, right? So this would be kind of the alternative method using the plus operator. Oops, I have to put in space here. Okay. So you can get the same result, but I think we would agree that this is much more streamlined and easy than trying to do it this way, where I have to use all of the pluses and this, and it really breaks up the flow of what it is, right? It's a little strange though, right? Until you get used to it, you're like, what? %D, %G, okay? And then you have this over here, but again, anything new feels strange and unusual. But then after exposure to it in Python, you'll recognize and appreciate this kind of formatting, okay? Whereas this, perhaps to the uninitiated, might be easier, but then, I don't know, my opinion is that it's really not as elegant, and it looks, it really breaks up the flow, okay? And again, you can give it a tuple of multiple values and stuff. And, as you would expect, here I've got 3 format operators. So Python's going to expect a tuple of 3 values, and if I give it a tuple of 2 or a tuple of more than 3, it's gonna complain, right? But here I can give it values like Joe Bruin 183, and these can all be replaced with variable names and stuff, or the actual values themselves. Okay, so that's using write and the format operators. An important thing is being able to specify where you want to save your files. And so Python has a way to interact with the file names and the directories and the folder system that exists on your computer, right? So there's the OS module. You just call import OS in case you need to work with directories or anything like that, okay? And so you can call OS get CWD. That's going to be get your current working directory. And here I'm just going to abbreviate it CWD, but or you can name it whatever else. And this is going to be the path. So on my computer, I stored in OneDrive Teaching 21 for Stats 21, and this is the folder, the directory for our class, and you can call it on yours, and it's obviously going to be different for you. When you provide a file name to Python, it's often going to be a relative path because it relates to the current working directory, but you can also ask for absolute paths, right? So here you can do os.path.absolute path, okay? And so if we said, what is the absolute path of output.txt, this is a relative path. It's a relative because it exists inside in relation to my current working directory. All I have to do is just take my current working directory, tack on a slash, and then output.txt. Okay, the output path starts at kind of the root directory. In our case, it's my D drive, and it's stored right here. Okay, and as always, you can read more about the OS functions and the documentation. There's lots of them. A lot of these are a little bit technical. But so here's just highlighting some of the ones that are probably the most useful. Okay, you can see if a file exists. So you can do os.path exists. Does this file exist? No, it does not. Okay, does output.txt exist? Yes, it does. Okay, is output.txt a directory? Nope. But inside inside my folder, I've got the .git directory. Okay, and I can say, is this a directory? .git a directory, and that comes back as true. Okay. You can list off. You can say os.list directory, current working directory, and then it will list off the contents of everything in that directory, right? So this is a lot. My slides and okay, everything. So everything has, I guess, 3 versions: the PDF, the IPy notebook, and the HTML generally. And then other stuff. A few. This is a directory, and this is a file. Okay, and again, just from the listing of the directory, you can't tell whether it's a file or a directory. So you can ask, is it a directory, and get a true or false. There's also an is file. Oh, okay. Yeah, is underscore directory and is underscore file. Yeah. So is it? Wait, what? Am I confused? There's underscores here, and I didn't use an underscore. Okay. All right. But anyway, this is something. So you do have to be careful, though. Okay, right? So generally, when you're working on your own computer, you probably won't do anything stupid like intentionally delete files and stuff. But it's possible, right? Like Python, with the OS module, you do have access to your files, and you could type in some commands that will delete some stuff. And also, this is a warning. If you download a Python script off the internet or a Python notebook file off the internet, and you just blindly start executing the code, if it loads up the OS module, it could mess up your computer. So so just be careful, right? Sometimes we don't take computer security seriously, and basically Python programs are programs, and if somebody wanted to write a malicious one that goes into your directory and deletes everything out of it, that is it could do that. It could do that. So don't. So you can download Python scripts off the internet. That's fine. But before you just blindly run it, look through it. Look through it. And if you see calls to OS, make sure it's not going to wildly just mess with your computer files, right? Because there's some people that, I don't know, for some weird reason get pleasure out of causing pain to others. So so anyway, just be careful. Okay. When you're dealing with files, and just in programming in general, a lot of things can go wrong, okay? In terms, not like we're deleting your files, but just like you expected a file to be there and it's not there. So Python's going to throw an exception, right? And so rather than just crashing your things, you can try to catch these exceptions and execute different code, right? So there is the try except kind of combination, which works very similar to if else. Okay, so so what you do, so here I said let's make a file and try to open bad file. Bad file is something that just doesn't exist, right? It's going to say no such file or directory bad file, right? Okay, but what we can do is we can do try fin is equal to open bad file, okay? And then and what Python will do is it tries to run this. It notices an exception here, right? We get a file not found error. Okay, it gets the exception, and so because this ran into a problem, it runs the code in the except block, okay, which is going to say something went wrong. Okay, so okay, it works exactly the way you would expect, right? It works just like an if-else. It tries this thing, if it and if it can, it will do it. And if this works without any problem, it does not execute the except portion. However, if this runs into a problem, and you can have multiple lines in the try, you can have a whole chunk of code there, and as soon as it runs into an exception, it's going to kick out of the try block and begin executing the exception block. Okay. There is a file structure called a DBM database. Okay. This is not like a SQL database or anything like that. It's a very simple file structure, and you know, it's a little bit different. It has more structure than just a text file, right? A text file just has lines of text. Okay, and the DBM has a little bit more structure, like a dictionary. Okay, so and this will store to a location on your hard drive. Okay, so you have to import the DBM library. So you call import DBM, and then you create you open a DBM connection using dbm.open. So it's similar to working with a file, except you're going to do dbm.open, and then here we're going to create a DBM file called captions. Okay, and C, the option C will be for create. Okay, if it doesn't exist, if it already exists, it's not going to overwrite. It's not going to overwrite. Okay, so here with the DBM, it works very similar to a dictionary, and you're going to provide it keys. Okay, so here is a key that's just arbitrarily called cleese.png. Okay, this is all of these things. John Cleese is an actor from Monty Python. Okay, the kind of the sketch comedy show, and so I guess that's kind of the theme, because this is a Python book. So anyway, we got so this is just a key. It's not referring to any. There's no file called cleese.png. There's nothing. It's just here's a key and here's the value, right? So it's just like you have keys and you got values, and it's just a string. Okay, it's not a file. It's just a string of a file name that on my computer doesn't even exist, and the value is another string. Okay, so it's a lot like a dictionary, except pretty much the keys have to be strings and the values have to be strings. Okay, and then later on, while you have the database connection open, you can ask what is the value associated with this key. Okay, and then it comes back with the string photo of John Cleese. There's a B in front of it because it's in binary mode, or byte mode. Okay, I don't something. But it's like a dictionary, right? Whereas you've already been working with open, at least with the word list file. Okay, that word list file has like 100 whatever thousand lines of words, and it just reads through them one by one, right? But you could set up a dictionary where you could look up a particular file or a particular key, and then you could have a file that is an actual dictionary where you look up the word, and then it comes back with another string, a definition. Okay, something like that. Okay, if you can add another key value pair, and so here we're going to do for I forgot, I modified this earlier. Okay, Jones is equal to this photo of Terry Jones, and then we went through, and then we'll print the we'll go through for key in database, print each key and the value. Okay, and so we have cleese.png and photo of John Cleese, and jones.png and photo of Terry Jones. And I forgot, I had added something here, and again, because with the database it doesn't wipe it out, I had added something, and so this is from a previous operation that I did, and it's not reflected in these steps that I took here. So just ignore this line for now. Okay. And then when you're done working with the database, you should close it. Okay, so you do db.close. Right. When you create the captions database in Python, it's going to add some files to your working directory. So here I just went, so using commands that we've learned, I've done for I in OS list directory. So it's going to go, so that's the directory listing of pretty much all the files, which is all of this stuff. And it's going to iterate through all of them. And then I just said, if it's a file, okay, so because I don't want directories, if it's a file and the string captions is in the name I, then print it out, and we get out captions.back.dat and .dir. Okay, these are just the files. And if you try to open these directly, they're not intended to be human readable. Okay, so there's parts of it are readable. Photo of John Cleese, photo of Terry Jones, but there's like a whole bunch of other stuff, right? This is not, it's not like output.txt, which writes directly what you told it to write. Okay. Okay. So one major limitation of the DBM is that it can only store strings or byte objects, right? If you want to store other objects that you've created in Python, like a list or a tuple or a dictionary or something, if you want to store other types of objects, you have to what we call pickle them. You have to pickle them. So it's the names are all kind of funny, but it's kind of the idea that you can save, I don't know, your vegetables for long term by, brining them in solution, and you're pickling them, and you can then leave them, store them for like several months and they won't go bad. Okay. So anyway, here you can pickle your Python objects, and what this is going to do is it's going to convert the object. Well, there's a few ways. Okay, so that here you can pickle them into strings that can then be written to the DBM, right? So this database that we've been working with, this DBM, is only allowed to store string objects. If you try to assign anything else, Python's gonna crash, or it's gonna cause an error. Okay, so here I create a list called T. Okay, the type of T is a list, and I'm going to open up my database. I'm going to say db open captions here, and then if I say let's create a key called list and store object T in there, it gives me a type error, and it says type error, values must be bytes or strings. Okay, so it's not going to let me assign a list into the DBM. Okay, so what I have to do is I have to import the pickling module. Okay, and there's dump and load. Okay, so dump will pickle the object, and the load will read it back, unpickle it. Okay, and then there's dump s. Dump s will convert it to a string. It'll pickle it into a string. Okay, so we call pickle.dumps on T. T again is this list, 1, 2, 3. Okay, so when I do pickle.dumps on T, and I ask, and I'm going to store that as an S. S is now a string, okay, and it's a string that looks like this. This is not meant to be read by humans. Okay, this is a string object. Okay, that it's a string representation of this list 1, 2, 3, right? Because inside the list, you might be like, well, why is it so hard to store a list, right? Why don't I just put quotes around this and make it a list, okay? Well, inside a list, there's quite a bit of structure in there, right? And we don't realize, but it's basically the list is a object of length 3, and each object is of type integer. And all of that information is stored in the list, and we can't really quite read it, but that information is stored. If we represent it as a string, it's going to look something like this. Okay, and then so with this thing being string and byte information, I can then use the DB that I've opened back here, and I tried to save the list here and it didn't work. I can now save it, okay? Because S is the string representation of the list. I can now store this into here, okay? And then we'll go ahead and close the database. And then so later on, now that I've pickled that list into the string, what I can do is I can retrieve it, okay? So I can say, like, okay, let's open that database back up. Let's retrieve the list, and it pulls back exactly that string that I stored there, okay? And then I want to say, well, this is not useful to me. I want it as a list. So I can then say pickle.load, load from a string, load S. Load S will load from a string, and then we say basically unpickle that object, and then it says, yeah, here you go. Here's the list. The list has the integers 1, 2, 3 in it. Okay, so so you can pickle these other objects and store it into a DBM. You just can't do it directly. You gotta pickle them first. Okay, does that kind of make sense? So the type of that output is list again. Yes. So this is a list. This is a list object that's identical to this. It's basically a copy of this thing. Okay, it's basically going to be a copy of this. It's going to be another list object, and this is a way for you to store Python objects that aren't strings into files for later retrieval. Okay, and so you can store things. You can pickle. You can also pickle objects directly to a pickle file. All right. And if you're going to do that, it can be useful to pickle multiple objects, and you can group multiple objects by grouping them together in a list or a tuple. Okay, so here I've got object 0, which is going to be file 1, which is a list of strings that says file 1 and something else. Object 1 is a list numbers 1, 2, 3. Object 2 is just a string by itself. Okay. And so here, we're going to create an objects.pickle file. Okay, so I'm going to say with open this thing. Okay, and then we're going to do write and B for binary, write in binary mode. So we're going to do with open as file, and then I call pickle.dump. Okay, there's no S here because I'm not trying to turn them into strings and to be read into the DBM file. Okay, so the DBM file is useful if you need kind of that dictionary structure with keys and values. But if you just want to save them away, okay, if you just want to save them away, you can just use dump without the S. And here I grouped the objects together in a single list, right? So pickle, you can only pickle one object, but you can group multiple objects into one object, right? So you can create a list of objects. And so, so here's a list of 3 objects, and I've put them in here, okay? And then we're gonna dump them into this file, which is the open connection to objects.pickle, okay? And so because I've done with, it's automatically gonna close the file connection here. All right, and then so later on, if you in another session or something else, you can send the pickle object here. Okay, what you can do is you open it back up. So we're going to open the pickle object, this time in read mode with the R, read mode binary, and so we're going to open this as a file, and then what we're going to do is we're going to load the pickle. Okay, so we're going to load that pickle. Okay, so we take the file here, this object here, we load that, and that's going to automatically, that's going to create back basically this exact object that it created here. And so here I do tuple unpacking. I'm going to unpack them into x1, x2, x3. I could have called them object 0, 1, 2, but I'm going to call them x1, x2, x3, and we're going to see x1 is exactly that list, x2 is this list, 1, 2, 3, and then x3 is going to be the string hello world. Okay, so that's pickling. Here's more documentation on pickling. Okay, and so you can all of these things can be pickled. So you can pickle I don't know, whatever. Okay, you know, when you're dealing with other data, things like a CSV file, then you know that's its own kind of format, and you can work with you know, later on we'll cover pandas. Pandas handles kind of CSV files and loads and reads data. But if you want to store Python objects themselves, generally pickling is the way we do it. Okay, so to save an actual Python object. Of course, if your scripts are all short and fast and you don't really need to save any of these things, it's not a huge deal. But in some cases, you might have a complex dictionary that took a while to build up, and you're going to want to store that somewhere. Okay, that covers pickling. There's a little bit of stuff on pipes and modules, but I think it's okay if I don't cover those topics. So I guess we'll end a little bit early today. That's all I got for you guys. I'll create another homework assignment in the coming days for that will look at NumPy and stuff. Oh, quiz answers. I totally forgot what my quiz answers were. Let me